Hello students, and I welcome you all in my online class. So today we'll do the limit chapter, that is from calculus portion. So in the last online class also we were doing the same chapter, that is limit. Okay, so today we are doing the same exercise, that is exercise 1, page number 244, and each question carries 4 marks. So in the last online class we did the section each question carries 4 marks, and we did question number 2 of question number 1 from each question carries 4 marks section. So today we'll do this question number 1, number 3. So you have to evaluate this limit. That means you have to find out the value of this limit. That is, you have to find out the limiting value of this limit. Okay. Now in this case the question is limit x tends to 0, 4 to the power x minus 1 divided by sine 2x. So you should know which is the variable and which is the constant out here. Since it is given limit x tends to 0, so here x is the variable and all of the terms are constant out here. That is, 1 is constant, 4 is constant, like that. Okay. So in this case we have to use the standard limits. That means you can convert this limit into standard form. Okay. So the standard form you can use here is limit x tends to 0, a to the power x minus 1 divided by x. This standard limit can be used because this 4 is a constant and power x is the variable out here and 1 is a constant here. So we can use the standard limit, limit x tends to 0, a to the power x minus 1 upon x. Okay. So which is equal to, what is the formula here? It is log a base e. And the formula that you can use in the denominator is, that is trigonometric function, limit x tends to 0. That is limit x tends to 0. This is sine x divided by x, which is equal to 1. Okay. Now you should divide both the numerator and the denominator by x out here, because there is no x out here, because you should have a to the power x minus 1 whole divided by x form, and in the denominator also you should have sine 2x divided by x form. So you should divide both the numerator and the denominator by x in this case. So which is equal to limit x tends to 0, 4 to the power x minus 1 divided by x divided by sine 2x divided by x. Is that clear? Now this numerator is in the standard form, that is first one. Now you should convert this denominator in the standard form. Since there is sine 2x here, so you should have 2x here also. So write down 2x. So multiply this x which is in the denominator by 2. Again you should multiply it by 2 here to cancel this 2. Because we are multiplying this x by 2 ourselves and it should be cancelled. So you have to multiply this denominator by 2. So that these 2 and 2 will be cancelled and you will get the same sine 2x by x form. Okay. So here, in order to convert this expression into this form, sin x by x form, so we have divided this sine 2x by 2 here out here. Okay, but we are multiplying this x by 2 ourselves, so you have to cancel it. So in order to cancel this 2, you have to multiply it by 2 in the denominator. Is that clear? So now this is in the standard form, 4 to the power x minus 1 upon x, and sine 2x by 2x is the standard form. So this is actually, this is half. This half is constant. This half constant can be taken outside limit. So which is equal to half into, now you can write down this limit wherever there is x, wherever there is a standard form. Okay. So you can write down this limit x tends to 0 both in the numerator as well as in the denominator. So you write limit x tends to 0, 4 to the power x minus 1 divided by x divided by limit x tends to 0. This is sine 2x divided by 2x. So I think you have understood it. Now you can use this standard form. So what is the value? So what is the value for the limit which is in the numerator? This is the standard form. What is the standard form here? Which is equal to half into, now what is it? Limit x tends to 0, 4 to the power x minus 1 whole divided by x. That is your log 4 base e. Log 4 base e divided by, in the denominator, what is the value of this limit? Limit x tends to 0, sine 2x divided by 2x is always 1. That is the standard form. So which is equal to 1. Okay. Now again you can simplify it further, which is equal to half log, what is 4 here? It is 2 squared. The base is e out there. Now you can use properties of logarithm out here. Because of that log, the power 2 becomes the coefficient. You know the properties of logarithm, isn't it? So is equal to half into, this is your 2 log 2 base e. So here 2 gets cancels. So which is equal to, what is the answer now? It is log 2 base e. So this is the final answer. So I think you have understood it. So you can copy it. So we'll do next question now. Now we are doing the next question, that is one number 5. You have to evaluate this limit. Find the value of this limit. Okay. The question is limit x tends to 0, a to the power alpha x minus b to the power beta x whole divided by x. So here also x is the variable. Here a, b, alpha, beta all are constant out here. So in this case it is given as a to the power x form. This b to the power beta x is also the form a to the power x form. So we can use here this formula, limit x tends to 0, a to the power x minus 1 whole divided by x, which is equal to, this is your log a base e. So you can use this standard limit in this case, okay? But there is no minus 1 out here. A to the power alpha x minus 1 should be there. So you can write it, but you have to cancel it because there is no minus 1 out there, okay? So is equal to limit x tends to 0, a to the power alpha x, then write down minus 1. But you have to cancel it, okay? Then first you write minus b to the power beta x. Then what do we write? Then you can write plus 1 whole divided by x. I think, is it understood now? I think I have understood it. So it is minus 1. You have to cancel it. So we have written here plus 1, okay? Now is equal to limit, this is your x tends to 0, within bracket a to the power alpha x minus 1 is kept within bracket. So here you can take minus as common. So within bracket b to the power beta x minus 1, this whole divided by x. Is that clear to all of you? So which is equal to, then you can split the term out here. So it is limit x tends to 0, a to the power alpha x minus 1 whole divided by x. Okay. Then what is the sign here? Minus. You can write down limit in the second term also, because the second term also contains x, isn't it? So wherever there is x, you have to write down that limit x tends to 0. So here also you can write limit x tends to 0, then b to the power beta x minus 1 whole divided by x. Is that understood now? So now you have to convert this term into that standard form. So instead of a there is a only, instead of a there is b, a to the power x form. But instead of x, what is x here? This is alpha x. But the standard limit is limit x tends to 0, a to the power x minus 1 whole divided by x. But in this case, what is x here? Alpha x. So you should multiply this x by alpha to convert it into standard form. So multiplied by alpha, but it should be cancelled. Here you should write alpha. Okay, this alpha gets cancels and you will get the same expression. Okay, here also you should convert it into the form of a to the power x minus 1 whole divided by x form. But instead of a there is b. It's okay. Okay, but instead of x there is beta x. So you have to convert this x into beta x form. So it should be multiplied by beta. But this beta should be cancelled. What do we write here? into beta. So is that understood now? So now in the next step, what do we write? So is equal to, now for this first term, this alpha is a constant. You can write it before limit. Alpha into limit x tends to 0, a to the power alpha x minus 1 whole divided by alpha x. Understood? Next, minus. So which is the constant term here? Which is the constant term which is free from out here? That is beta. So beta is taken outside limit. So minus beta into limit x tends to 0, b to the power beta x minus 1 whole divided by beta x. So is that understood now? So you can use the standard limit now. So which is equal to alpha into, now this is the standard form. Which standard form is this one? That is standard form. Limit x tends to 0, a to the power x minus 1 whole divided by x. So instead of x, here it is alpha x. So what is the formula? Log a base c. Okay. So it is alpha log a base c minus beta into. So instead of a, there is b. And instead of x, there is beta x. What is this formula? It is log b base c. This one will be log b base e. So this is the final answer. So I think this is also understood. You have understand it. Okay. So I think you have understood it. So this is the answer. That is alpha into log a base e minus beta into log b base e. So now we'll do the next question now. Now we are doing the next question, that is one number 6. The question is, you have to evaluate limit x tends to 0 log of within bracket 1 plus 3x whole divided by x. So in this case, which standard limit is used? That is limit x tends to 0 log of 1 plus x base e whole divided by x, which is equal to 1. Okay. Now in this case, since log is given out here, you have to use this formula. Understood? So I think you have understood it. So log of 1 plus 3x divided by x. But instead of x here, what is here? It is 3x. So this x should be multiplied by 3 to convert it into that standard form. So is equal to limit, this is your x tends to 0 log of 1 plus 3x. Now if there is no base, it is understood the base is e out here. Okay, so we can write here base e divided by, since there is 3x here, you should multiply this x by 3 to make it 3x, but it should be cancelled because we are multiplying this x by ourselves only. हामी आफै यो x लाई 3 ले मल्टिप्लाई गर्दैछौं, तर त्यो 3 लाई चाहिँ हामीले के गर्नुपर्छ, क्यान्सल गर्नु छ। त यहाँ के गर्छौं हामी, 3 into 3 लेख्छौं, so that these 3 and 3 will be cancelled and you will get the same expression out here. Is that clear? Now this 3 is a constant which is free from x. You can write it before limit. So which is equal to 3 into limit, this is your x tends to 0 log of 1 plus 3x, the base is e whole divided by 3x. So which is equal to 3 multiplied by this value of this limit is always 1. So which is equal to, what is 3 ones are? This is 3 ones are 3. So this is the final answer. So I think you have understood it. Okay. Now we'll do the next question. Now we are doing question number 7. The question is, you have to evaluate this limit. Limit x tends to 0, 2 to the power x minus 1 whole divided by, within square root 1 plus x, then minus 1 is there. Okay. Now, first of all, since you have to convert into standard form, first of all, you rationalize the denominator. What is the meaning of rationalizing the denominator? That means you have to remove square root from the denominator. Rationalizing the denominator means you have to remove square root from the denominator. So by which expression will you multiply this denominator? By conjugate sort, isn't it? That is, you have to multiply both numerator and the denominator by within square root 1 plus x. Since there is minus 1, you have to multiply it by opposite sign, that is plus 1. Okay, so is equal to limit x tends to 0, it is 2 to the power x minus 1. It should be multiplied by root over 1 plus x plus 1 whole divided by within square root over 1 plus x minus 1 into root over 1 plus x then plus 1. Is that understood? That means we are rationalizing the denominator out here. Rationalizing means we are removing square root from the denominator. So by which expression will you multiply both numerator and the denominator? By the expression we can multiply both numerator and the denominator by root over 1 plus x plus 1. हामीले यहाँ के गर्नुपर्छ? Opposite sign ले चाहिँ multiply गर्नु पर्यो. That is root over 1 plus x plus 1 ले माथि र तल multiply गर्नुपर्छ. ठीक छ? बुझ्यो हैन? So which is equal to limit. Now this is x tends to 0. So numerator is kept as it is, 2 to the power x minus 1 into root over 1 plus x plus 1 whole divided by. Now in the denominator, which formula is used? Here a minus b into a plus b, isn't it? This root over 1 plus x is taken as a. So what is a minus 1 into a plus 1? That is a square minus b square. So it is, what is a whole square here? Here a is root over 1 plus x. So root over 1 plus x whole square, then minus what is b whole square? That is your 1 whole square. So is that understood now? So which is equal to limit, this is your limit x tends to 0, then it is 2 to the power x minus 1 into within square root 1 plus x plus 1, this whole divided by. Now in the denominator, what is within root 1 plus x whole square? It is 1 plus x. This is 1 plus x, then minus 1 whole square is minus 1. Here 1 gets cancels. So I think you have understood. You have understood it. Now in the denominator there is only x out there. So you can write x below this expression, that is 2 to the power x minus 1. Okay, so that we can convert it into a standard form. So is equal to limit x tends to 0. Now this x is written below 2 to the power x minus 1. So it is 2 to the power x minus 1 whole divided by x into, since this root over 1 plus x plus 1 contains x out here, variable x, so you can write limit for this expression also. Okay, into what? Limit x tends to 0 within bracket root over x plus 1 plus 1. Is that clear? So which is equal to, now this is a standard form. Limit x tends to 0, a to the power x minus 1 whole divided by x. So what is this formula? It is log a base e, but instead of a there is 2. So what can I write here? It is log 2 base e into. Now you can put x is equal to 0 out here, but actually x is not exactly equal to 0 in this case. I told you about this limit, isn't it? But x is approaching towards 0. X is approaching towards 0 means x may take the values like 0.9, 0.99, 0.999, 0.99999, 4 nines are there, 0.99s are there. Okay, so approximately it is tending towards 0. So you can put x is equal to 0, or it may be like that. It may be 0.999, 0.9, 0.9, 0.99, 0.999, 0.49s, 0.59s are there. that is approaching from the right hand side, because all these 0.9, 0.99, 0.999 are greater than 0. So less than 0 means, what do you mean by less than 0? Less than 0 means that is from negative sign, right? That is from negative sign. You can write minus 0.1, minus 0.1, minus 0.1, it is approaching towards 0. Minus 0.1, it is approaching towards 0. Minus 0.01, also approaching towards 0. Which one is greater out here? Minus 0.1 and minus 0.01 are there. So among these two numbers, minus 0.1 and minus 0.01, which is greater? That is, minus 0.01 is more than minus 0.1. That is, it is approaching towards 0. Again, minus 0.001, minus 0.0001, you may have minus 0.40 and 1, you may have minus 0.50 and 1, like that. That is, it is approaching towards 0 from the left hand side. Is that clear to all of you? So here approximately you can take the value is equal to 0. That means you can give the limiting value of x here as 0. That is, within bracket you can write root over 1 plus 0 plus 1. Okay? It tends towards 0, right? It tends towards what? 0. Is that clear? So which is equal to, this is your log 2 base e into within bracket, that is what is square root of 1? That is 1. So it is 1 plus 1, which is equal to 1 plus 1 is 2. It is taken outside, it is taken in the front of log 2. So it is 2 log 2 base e. So 2 log 2 base e is the final answer. So I think you have understood it. So we'll do the next question now. So now we are doing this question, that is, you have to evaluate this limit. So this is important question, right? So one number 8, that is limit x tends to 0, e to the power x plus e to the power minus x minus 2 whole divided by x square. So actually this problem is from class 11. So in class 12 also you may get the question like this in your higher secondary examination. In 2015 and in 2016 there is some question from this limit chapter also, that is which carries 2 marks, I think. Okay, so this question might come in your higher secondary examination also. Okay, so you should know how to evaluate this limit. Okay, so the question is, you have to evaluate this limit. Limit x tends to 0, e to the power x plus e to the power minus x minus 2 whole divided by x square is there. Okay, now let us simplify it. Since exponential function is given out here, so you should write it in the form limit x tends to 0, e to the power x minus 1 whole divided by x, which is equal to 1. Okay, now in this case let us convert this e to the power minus x into the form of 1 upon e to the power x. This is e to the power minus x is given. If you simplify it, it becomes 1 upon e to the power x, isn't it? So which is equal to limit x tends to 0, this is e to the power x plus 1 upon e to the power x minus 2 whole divided by x square. Is that understood? So which is equal to, now it is limit x tends to 0. Now in the numerator, what's the LCM? In the numerator, e to the power x is the LCM. So if you simplify it, e to the power x into e to the power x is e to the power 2x. Then e to the power x, this LCM is divided by e to the power x, that is 1. So 1 ones are 1 minus, below 2 there is 1. This e to the power x is divided by 1. You will get e to the power x multiplied by 2. What do we get? Minus 2 e to the power x. Understood? So into, there is 1 upon x square is there, so you should write it out here. Clear? So is equal to limit x tends to 0. Now in this case you can use the form here, a square plus b square minus twice ab. You know the formula, isn't it? A square plus b square minus twice ab is a minus b whole square. Now you should write it in the form of a square plus b square minus twice ab. So here what is a whole square? E to the power x whole square plus what is b whole square? It is 1 whole square minus 2 into what is a? E to the power x into what is b? 1 whole divided by e to the power x into 1 upon x square. So I think you have understood it up to here. Okay. Next. Now let us simplify it. So which is equal to limit. This is your x tends to 0. Now in the numerator, what can you write? A square plus b square minus twice ab. What is the formula? It is e to the power x minus 1 whole square divided by, there is e to the power x into 1 upon x square. Is that clear to all of you? Now you should convert it into standard form. So what is the standard form out here? E to the power x minus 1 whole divided by x. So you should write this x square below this e to the power x minus 1 whole square. So which is equal to limit, this is x tends to 0, e to the power x minus 1 whole square divided by x square into 1 upon e to the power x. So is that understood now? So wherever there is x, you have to write down the limit. But before that, since whole square is for both numerator and denominator out here, so you can write it within whole square, fraction whole square. So how will you write it? So you can write it within whole square, that is limit x tends to 0, e to the power x minus 1 upon x whole square into 1 upon e to the power x. So now in this case, wherever there is x, you have to write down the limit out here. So in the next step, you have to write down the limits now. So you can write down this limit within whole square, because there is e to the power x minus 1 whole divided by x. That is the standard form, right? So which is equal to within bracket limit x tends to 0. So it is put within whole square. So limit x tends to 0, e to the power x minus 1 upon x whole square into 1 upon. So this e to the power x also contains x. So in this case also you have to write down the limit. That is limit x tends to 0, e to the power x. Is that clear? So now what is the value of this limit? That is the standard limit 1. So this is your 1 whole square into 1 upon. So here you can put x is equal to 0 out here. So if you put x is equal to 0, e to the power 0, that is it is x tending towards 0. That is, it is nearer and nearer to 0, isn't it? So that means you can put x is equal to 0 out here. So it is 1 upon e to the power 0. So what is e to the power 0? Something to the power 0 is always 1. So something to the power 0 is always defined as 1. That is, it will be e to the power 0, isn't it? So e to the power 0 is always 1. So what is the value of this limit? The value of this limit is 1. So this is the final answer. So I think you have understood it. You can copy it. So we'll do the next question now. Now we'll do the next question, that is number 2. You have to prove that. That means you have to evaluate the limit. The answer is given in the question itself. So that is number 2. We'll prove number 2. That is limit x tends to minus 2 log of x plus 3 divided by x plus 2 is equal to 1. Since log is given out there, so you have to convert this given problem into the standard limit form. The standard limit form is limit x tends to 0 log of 1 plus x base e whole divided by x is equal to 1. तो यहाँ क्वेश्चन में log दिएको छ भने तिमीले कुन चाहिँ स्ट्यान्डर्ड लिमिट फर्ममा लान्छौ यसलाई limit x tends to 0 log of 1 plus x base e whole divided by x is equal to 1. So actually base is not written out here. So it is understood the base is e always, right? If the base is not written in terms of log, you have to think that, or it is understood that the base is always e, log base e, right? So let us write down the left hand side now. So LHS is equal to limit x tends to minus 2. This is your log of x plus 3 base e divided by x plus 2. So how will you convert this given limit into that standard form? The standard form should be log of 1 plus x divided by x. Okay. Now in this case we should do the method of substitution. So you know the substitution method, that is any one of these variables, any of the variable out here should be replaced by a new variable. That is known as the method of substitution. So let us assume this x plus 2 as z. So here previously the variable was x. So if you assume x plus 2 as z, then z will be the new variable. Okay. So let us assume let z is equal to x plus 2. So in the denominator there is x plus 2. We have assumed this x plus 2 as z. Okay. But let us get the value for x also, because there is x plus 3 out here. You have to put the value of x in the numerator also. So what is the value for x from here? So x is equal to, this is your z minus 2. But in this case you have to change the limit also, because before substitution x was the variable, and after substitution which is the new variable, that is z. So when x tends to minus 2, what does z tend to? यदि यहाँ तिमीको x tends to minus 2 भयो भने z tends to कति हुन्छ त्यो चाहिँ निकाल्नु पर्छ. ठीक छ? किनभने we are changing the variables. We are changing the variables out here. You have to change the limit also. Before substitution x was the variable, after substitution which is the new variable, that is z is the new variable. That means when x tends to minus 2, what does z tend to? Suppose if you put x is equal to minus 2 out here, यदि तिमीले यो x को जग्गामा minus 2 हाल्यो भने minus 2 plus 2 के हुन्छ 0. Understood? यहाँ x is equal to minus 2 यसमा हाल्दियो भने minus 2 plus 2 के हुन्छ 0. That means when x tends to minus 2, z tends to 0. Is that clear now? So you should write here, when x tends to minus 2, z tends to what? 0. Is that understood? Now we will write down the limit z tends to 0, because new variable z is used out here. Okay. So this left hand side now becomes, so LHS is equal to limit. Now instead of x tends to minus 2, what do we write? Z tends to 0. This is your z tends to 0. Then log of, so within bracket, what is the value for x out here? What is the value for x? It is z minus 2 plus 3 whole divided by what is x plus 2? It is z. And what is the base here? The base is e. So I think you have understood it. So now, which is equal to, now you can simplify it further. Limit z tends to 0. Now in the numerator it will be log of, within bracket, z plus 1, the base is e, right? Plus 3 minus 2 is plus 1 whole divided by z. Now compare this standard limit and this limit. Limit z tends to 0 is out here, but instead of z there is x here. And it is log of 1 plus x, it is log of 1 plus z divided by z. Instead of x here, z is there. So this is the standard form. So what is the value of this limit? Well, directly you can write 1. So it is proved. That is, we have proved that this LHS is equal to RHS. So I think you have understood it. So you can copy it. We'll do the next question now. Now we'll do question number 3. Number 2 is proved that this is question number 3. It is given limit x tends to e log x minus 1 whole divided by x minus e, which is equal to 1 upon e. The answer is given in the question itself. That is 1 by e. You have to prove 1 by e, right? Since log is given out here, what is the formula that you can use here? Or standard limit that you can use here is limit x tends to 0. This is log of 1 plus x base e whole divided by x, which is equal to 1. Okay? Now you have to convert this limit into that standard form. So let us write down LHS now. So LHS is equal to limit x tends to e. This is your log x minus 1 divided by x minus e. Okay? So here, which is the variable and which is constant out here? Since it is given x tends to दिएको छ यहाँ, but x चाहिँ variable भयो and x tends to e चाहिँ के भयो? Constant भयो. So you have to write down the answer in terms of e. That is, you have to prove 1 upon e. Okay? So let us do the method of substitution out here. So let us assume this denominator again. So what is the denominator here? X minus e. Let us assume it as z again. So let z is equal to x minus e. Let us get the value for x here again, because in the numerator you have to put the value for x. So x is equal to, it is e plus z. X is equal to, what is here? It is e plus z. Now we have to change the limit. You know how to change the limit, isn't it? So it is given x tends to e. Suppose if you put x is equal to e, what do we get? E minus e is 0. That means z is equal to 0. So whenever x tends to e, z tends to 0. So when x tends to e, that is z tends to 0. That means we are changing the limit here again, because we are doing the method of substitution. Okay? So now this left hand side now becomes limit. So instead of x tends to e, you have to write z tends to 0, right? Then log of, what is x here? It is e plus z minus 1 whole divided by z. So I already told you that whenever there is no base for log, it is understood that the base is e out here. That is log base e. But you don't have to write it. It is not necessary to write down the base e. But if there is no base e out here, it is understood that the base is always e. Understood? Now, instead of 1, what will you write? Instead of 1, you have to write log e now. यो 1 को सट्टामा अब हामी के लेख्छौं? log e लेख्छौं. किन log e भनेको याद छ सबैलाई? log e base e is always 1, right? So let us write here. And so left hand side now becomes is equal to limit. This is your z tends to 0 log of e plus z minus, instead of 1 you write log e whole divided by z. So I think you have understood it. Now what is there in the numerator? It is log a minus log b. So you know the properties of logarithm. What is log a minus log b? It is log of a by b. So which is equal to limit z tends to 0 log of a by b. What is log of a by b? It is e plus z divided by e whole divided by z. Is that understood now? So this is your log of a by b. Okay? Now this a by b form, e plus z divided by e, you can separate the term here like e by e plus z by e, isn't it? So to convert it into standard limit form, you have to separate this fraction. So which is equal to limit z tends to 0 log of, separate the fraction here. What is e by e? That is 1 plus, then what do we write? Z by e, this whole divided by z. So I think you have understood it. Now this logarithm can be converted into standard form. This limit can be converted into standard limit form. So what is the standard limit here? Limit x tends to 0 log of 1 plus x whole divided by x. But instead of x, what is there? It is z by e. Instead of x here, there is z upon e. So you should divide this z by e again out here to convert it into the standard form. So z by e into, so we have divided this denominator by e, okay, but it should be cancelled. So what will you write here? 1 upon e. If you write 1 upon e, this e and e will be cancelled and you will get the same expression which is here. Okay, so z by e into, you should write, in order to cancel this e, you should write into 1 upon e. Okay, so now this 1 upon e is free from z, so it is a constant quantity. Okay, now this 1 upon e can be taken to the front, that is before limit. You can write this 1 by e in front of that limit. Okay, so what do we get now? Is equal to 1 upon e into limit, this is your z tends to 0, log of 1 plus z by e divided by z upon e. So now you have understood it. Okay, so which is equal to 1 upon e into, what is the value of this limit? This is a standard form, which is equal to 1. So you should write here 1. Okay, so what is the answer? That is 1 upon e. So it is proved. So I think you have understood it. So you can copy it. We'll do the next question now. Now we are doing question number 4, that is number 2. Prove that limit x tends to 0, p to the power x minus q to the power x divided by tan x is equal to, you have to prove that log of p by q. Okay, now since limit x tends to 0 is given, so x is the variable out here and this p and q are constant. Okay, now since this is the base, this is the power, this base is a constant, p is the base, that is a constant, and here power x is the variable. So in this case, which standard limit is used? You can use this limit, that is limit x tends to 0, a to the power x minus 1 whole divided by x is equal to, this is your log a base e. Okay, so if you don't write e there, it will be log a. So it is not necessary to write down e, but we have written base e out there, so let us write base e out here. Okay, suppose this is base e, right? You can write it base e. Okay, so if there is, I already told you that if there is no base for log, it is understood that the base is e always. Okay, now let us prove it. So LHS is equal to, so what is LHS out here? It is limit x tends to 0, p to the power x minus q to the power x divided by tan x. Okay, now in this case, in the denominator, you can use this formula, limit x tends to 0, sin x by x is equal to 1, and limit x tends to 0, cos x is also 1. Okay, because tan x is given out here. So first of all, you should have x here, isn't it? So first of all, you have to divide both the numerator and the denominator by x. So let us divide it. Okay, so is equal to limit x tends to 0, p to the power x minus q to the power x divided by tan x divided by tan x upon x. Is that understood? So now what will you do in the next step now? What will you do in the next step now? Now you can write down limit for both numerator as well as denominator, right? So let us write it. So which is equal to, in the numerator you write down limit, this is x tends to 0, then write down p to the power x minus q to the power x divided by x. In the denominator also you can write down the limit, that is limit x tends to 0, this is your tan x upon x. Okay, now I think you have understood it. Now you should convert it into standard form. This is standard form, a to the power x minus 1 all divided by x. So there is no minus 1 out here. So you have to write minus 1 out there. Okay. So this numerator can be converted into standard form. So which is equal to, now in the numerator you should write here limit x tends to 0. This is p to the power x minus 1. Okay. So we have added minus 1 out there, but it should be cancelled. So first you write minus q to the power x, then you have to write plus 1. So whole divided by, this is your x. So I think I've understood it. Now in the denominator also you have to simplify it. So this is limit x tends to 0. So how will you write that tan x? It is sin x by cos x, right? So this is your sin x upon cos x into, then 1 by x is also there. So you can write 1 upon x. Now you can easily convert all this expression into that standard limit form. So we have written here these standard limits. So we can convert this expression into all these standard limit form. So which is equal to, in the numerator you can write here limit x tends to 0. So it is p to the power x minus 1 whole divided by x. Is that clear? So now there is minus sign out here, minus. So wherever there is x, you have to write down the limit. Okay. So this limit is for only the variable x. So since q to the power x and x is there, so you have to write down the limit out here. That is limit x tends to 0, q to the power x. Now because of this minus sign, so minus into plus will be minus 1 whole divided by x. So is it understood? So this is separated. This expression is separated. That is p to the power x minus 1 whole divided by x. Minus is taken common here, within bracket q to the power x minus 1 whole divided by x. And you have to write down limit for both these expressions. So we have written limit x tends to 0 for both the expressions. Okay. Now in the denominator you should write limit x tends to 0. Now this is the form sin x by x. So this x is written below sin x. Okay. Now it is 1 by cos x. So into 1 upon, you can write here limit x tends to 0 cos x. So for cos x also you can write down the limit. So I think you have understood it. Okay. So which is equal to, now in the numerator, what is the value of this standard limit? That is a to the power x minus 1 whole divided by x when limit x tends to 0, log a base e. So here it is log p base e. It will be log p base e minus, similarly what is the second limit? Limit x tends to 0, q to the power x minus 1 whole divided by x. What is it? It is log q base e. It is log q base e whole divided by, what is the value of this limit? Limit x tends to 0, sin x by x is always 1 into 1 upon, what is limit x tends to 0 cos x? It is always 1. Okay. So now the denominator is 1, you don't have to write it. Okay. If the denominator is 1, you don't have to write 1 in the denominator. Understood? So now it is log a minus log b form. What is log a minus log b? That is log of a by b. So it is log of, you can write within bracket p by q, and what is the base here? The base is e. So we have proved the given result. Okay. So I think you have understood it. So you can copy it. Now we'll do the next question now. Now we are doing the next question, that is number 5. You have to prove that limit x tends to 0, sine of log of 1 plus x whole divided by x is equal to 1. So first of all, it is the sine form. You should write it in the form of sin x by x form. So instead of x, what is there? Log of 1 plus x, isn't it? So in order to convert this into the form of sin x by x form, you know that limit x tends to 0, sin x by x is always 1. So instead of x, there is log of 1 plus x. So you should convert it into the form of sin x by x form. So how will you write sin x by x form here? Sine of log of 1 plus x divided by log of 1 plus x should be there. So that means you have to multiply and divide this expression by log of 1 plus x first. That is multiplying both the numerator and the denominator by log of 1 plus x. Because instead of x there is log of 1 plus x. त यसलाई हामी के गर्छौं sin x by x फर्ममा लान्छौं. तर x को सट्टामा के छ यहाँ log of 1 plus x. त यसलाई sin x by x फर्ममा लानु हो भने माथि र तल हामी केले डिभाइड गर्छौं माथि र तल हामी केले मल्टिप्लाई गर्छौं log of 1 plus x ले. So this is your left hand side. Let us write down left hand side. Limit x tends to 0. This is your sin of log of 1 plus x divided by x. So this is a sin x form. Instead of x there is log of 1 plus x. Okay, is equal to limit x tends to 0. So this is sin of log of 1 plus x divided by. So if you want to convert into sin x by x form, you should divide it by log of 1 plus x. So this is your sin x by x form is there. Is that clear? Into, now we have divided by log of 1 plus x here. But it should be cancelled, isn't it? So if you want to cancel it, so you have to multiply it by log of 1 plus x divided by x. So now I think you have understood it. Okay. Now for both this expression, these are the variables here. For both the variables, you have to write down the limit. So which is equal to limit. This is your x tends to 0. This is sin of log of 1 plus x divided by log of 1 plus x into. Okay. Now again for the second expression, you have to write down the limit because this is the term containing x, right? So limit x tends to 0, log of 1 plus x divided by x. Is that understood now? So which is equal to, what is the value of this limit? What is the value of this limit? That is 1. This is sin x by x form. Sin x by x form is 1 into, that is your log of 1 plus x divided by x form. That is also 1. So 1 1s are 1. So we have got the answer. So I think you have understood it. So which is equal to 1, proved. Okay. Now we'll do the next question now. Now we are doing question number 2, number 7. You have to prove that limit x tends to 0. Here x is the variable. In the numerator log cos x is given, divided by, in the denominator it is given as sin square x. So what is the value? What is the limiting value of this function? That is minus half. This is the limiting value, not the exact value of this function, right? So you have to prove the limiting value of the function as minus 1 upon 2. Okay, so let us write down this left hand side now. So is equal to limit x tends to 0, log of cos x divided by, this is your sin square x. Okay, now you have to simplify it first, and since log is there, so you have to convert into the form of limit x tends to 0, log of 1 plus x divided by x, which is equal to 1. So you have to convert this given expression into that form, log form. Okay, now since it is given as log of cos x, यहाँ हाम्रो के छ cos x छ भने यो sin square x लाई पनि हामी cos x मै चेन्ज गर्छौं. So you know the formula of sin square x, isn't it? What is the formula for sin square x? It is 1 minus cos square x. You know that, isn't it? So is equal to limit, this is your x tends to 0, log of cos x divided by, what is sin square x? It is 1 minus cos square x. Okay. Now again you can use the formula here, 1 minus cos square x. Which formula is used? A square minus b square. That is from your algebra portion. So a square minus b square is a plus b into a minus b. So which is equal to limit x tends to 0. This is your log of cos x divided by, it is 1 plus cos x into 1 minus cos x. Understood? So a square minus b square form is used. That is a plus b into a minus b. So I think you have understood it. So now, if you put x is equal to 0 directly out here, for this 1 minus cos x, if you put x is equal to 0, cos 0 is 1, 1 minus 1 is 0, 1 minus 1 is 0. And something divided by 0 is meaningless, that is undefined. Understood? So something divided by 0 is always undefined. So because of this 1 minus cos x, we are getting undefined term. But if you put x is equal to 0 out here, we are getting cos 0 is 1, 1 plus 1 is 2. But in the numerator, we are getting 2 also. So in this case, since we are getting for this 1 minus cos x, when you put x is equal to 0, we are getting 0 out here. And something divided by 0 is undefined. That is your meaningless. But in this case, for 1 plus cos x, if you put x is equal to 0, we are getting 2 out here. Okay? This is 2 and this is your 0. So you have to separate this part. Okay? So is equal to, so you should write here, limit x tends to 0, 1 upon 1 plus cos x into. Now it is separated. हामी यसलाई छुटाउनु पर्यो. तो 1 plus cos x ले चाहिँ 2 दिदैछ. त छुटाए हामी. Into. अब यहाँ लेख्ने limit x tends to 0. Limit x tends to 0. Then what do we write here? Here you can write log of cos x divided by, it is your 1 minus cos x. Understood? So हामीले यहाँ के गर्यौं, log of cos x divided by 1 minus cos x भने लिमिटै लगायौं. अगाडि पनि लिमिट लगाए because there is 1 plus cos x is there. So here you can put x is equal to 0 here because we are not getting here undefined value. That means we are getting 2 in the denominator if you put x is equal to 0. So is equal to 1 upon 1 plus, you write here limit x tends to 0 cos x into. Now in that case, since you have to prove minus 1 upon 2, let us take minus common out here. So it will be cos x minus 1, isn't it? So into minus is taken common, limit x tends to 0, minus is taken common out here. Then it is log of cos x divided by. If you take minus common, this denominator now becomes cos x minus 1. So I think you have understood it. Okay, so which is equal to, now this minus is taken outside, minus 1 upon 1 plus, what is limit x tends to 0 cos x? That is always 1, you know that, isn't it? So into, this is your limit x tends to 0 log of cos x divided by cos x minus 1. So I think you have understood it. Now this limit x tends to 0 log cos x divided by cos x minus 1, you should convert it into standard form. What is the standard form out here? Limit x tends to 0 log of 1 plus x divided by x is equal to 1. So let us assume this denominator as z. That is cos x minus 1 should be assumed as z. So let z is equal to, this is your cos x minus 1. So let us get the value for cos x here again, because in the numerator there is log of cos x and the value of cos x should be put out here. Okay, so or what is the value for cos x is equal to, what is cos x is equal to? It is 1 plus z. Now we have to change the limit here also. Since we have done the method of substitution here, before substitution x was the variable, and after substitution, which is the new variable? Z is the new variable out here. Okay. Now, when x tends to 0, what does this new variable z tend to? When x tends to 0, what does z tend to? So, if we put x is equal to 0 here, cos 0 is 1, 1 minus 1 is 0. That means z is equal to 0. So when x tends to 0, z also tends to 0. So here you write, when x tends to 0, z tends to 0. Understood? So now write down. So we have changed the limit out here, which is equal to minus 1 upon 1 plus 1 is 2. So here limit Instead of x tends to 0, you write down z tends to 0 log of within bracket. Instead of cos x, what will you write? 1 plus z. It will be 1 plus z. This whole divided by, what is cos x minus 1? It is z. So I think you have understood it. Okay. Now we have converted the given limit into the standard form so that we can easily put the value of that limit. Okay. So is equal to minus half into, compare this limit with that standard limit. Instead of variable x, there is z. Okay. Limit z tends to 0. Here is limit x tends to 0, log of 1 plus z divided by z, there is log of 1 plus x divided by x. So same standard form is out here, only the variable is changed. Okay, so what is the value of this limit? This is 1, which is equal to minus half. So which is equal to right hand side. So it is proved. So I think you have understood it. So this question is also very, very important. Okay, so now today we did some problem from limit. So you can revise it at home. Okay, so if you don't understand anything out here, you can repeat the video, or if you repeat the video, you can understand it. But if you again don't understand it, then you can ask me or you can comment me. Okay, so this much is for today. So in the next class, we'll do more problems on limit. Okay.